All right, so we got the snake sitting on the board, but let's go and make it move. And in order to do that, we're going to need to create a sort of a game loop. So let's literally add a function here. So a function game loop, and part of it is going to be calling the draw. But in addition to the draw, we're going to need to also maybe like update the coordinate. So I'm going to call game loop once here. But we got to do two things. Well, a few things. One of them is that we need to call game loop repeatedly. Now, when I was doing this in the Brick Breaker game, I used a window request animation frame to do this. So what that gives you is a sort of a smooth pixel level animation at 60 frames per second. I'm going to show you a different way to do this, which for this particular game, it's going to work fine, especially since like the experience of like playing the snake game is like this moves cell by cell. So you don't need that level of a highly optimized movement. Okay, so we're going to be using a function. And this function is called setInterval, right? And setInterval takes two things. One of them is a function argument, a callback. So that's going to be our game loop. And the second thing is going to be some like a number as a delay, right? So it uses this number to wait, and then when that delay is over, it's gonna call this function again. Well, that like just as a footnote, that's not quite exactly entirely what happens. It doesn't like literally call this function. It puts it in something called an event loop, but that's a discussion for a different lecture. For our purposes, the way we can think about it is that we're putting some value here in milliseconds, and I can just hard code that value, or I can like give it it's better to like define it, kind of like the grid size, like don't use magic numbers. So we're gonna call this a tick rate, and I'm gonna give it 150 milliseconds. So let's take this and give it here. Oops. All right. So this is right now basically like every 150 milliseconds this function is being called, but all it is doing is just keep cleaning the board and drawing the snake, cleaning the board and drawing the snake. But for us to make the snake move, we need to update maybe its coordinate, right? So we can create like another function, update, and so we call the update, and then we draw, and we call the update and we draw. And what I want to do in the update is sort of a classic snake movement algorithm, is that I'm going to start taking the head. So that would be at index 0, right? So this position, like this one. And then what you want to do with the head is to move the head to kind of like calculate the new head, where the new head goes. And so the new head needs to have like x and y, and we can use like a velocity vector to define the direction which way it moves. Like its velocity should always be like 1 pixel at a time, but we want to know if the head like moves in the x-axis or in the y-axis, it goes up or it goes down, it goes left or it goes right. So let's like create a direction, like an initial direction, and so we can use like a x and y for the values of the magnitude and the direction of the velocity vector. So if I like give it y0, it means that it's not going to go up and down. If I give the x like 1, it means that it's going to go, this just blanked out because there is like a syntax error here. Okay, so if I give it x1 means to the right, so it sort of moves to the right. If it was -1, it should like go backward, right, move to the other direction. So let's uncomment these again. So now what we will do is we go and say take the head.x and times it by like the direction, and then do the same thing for the y coordinate. Now what we will do in a later video is like to hook this up to your keyboard, so that you can control, like you would use the arrow keys to change the direction, and that would affect the movement of the snake. But right now we'll just make it move, and we'll leave that to a different video. Okay, so I have a new head. So what you do is you want to add this new head to this snake array like this. So what should happen like after I did the update, it should like the x needs to be like 11, y needs to be the same thing. So this needs to be added, and then after you added this, you're gonna go and like remove this one, right? So like in the first position of the snake is this, right? The second position is supposed to be this, and this way it will appear as if the snake moved like one cell to the right, because you put a new head here, and then you remove the tail, right? And now it appears like it moved one cell to the right. So then it's just manipulating these cells in this array, and there are many different ways that we can do that. Here is one strategy. If I want to add to the front, like add as the first element of this, I can say a snake dot on shift and then give it the new head. This just adds a value to the beginning of the snake, whereas when you do something like push, it adds to the end. Okay, and then what I want to do is I want to remove the last element, so I can do the opposite of push, which is like pop. So snake dot pop, that will pop the last element. Okay, so if we save this, all of a sudden our snake is gonna start moving. Oh, sorry, I multiplied this rather than adding it. So there you go. Right, it kind of like moves to the right, and the reason it wraps around is because my cell is really just a 1D array. So in your head, you should think about this whole thing kind of, each row comes after the previous row. So when this like finishes, like the snake is imagine the snake is just continuing in one long row, but we have broken the row into like several row segments. Okay, so that's the gist of the movement. And now that we have the infrastructure that allows us to update the game and run the game, if we were to get hold of what the direction array or object is, and like hook that up to our keyboard, then we could actually control where the snake goes. So we're going to be doing that in the next video.